Previously on Big Man Black T-Shirt. Hey guys, we're back for part 2 of the CNC Complete project. We're picking up with the cam, if I remember correctly. We'll go through the cam. I make several mistakes. I fix most of them. One of them I don't. See if you can catch it. And then we wrap it up. So I hope you got something out of it. Here we go. Let's get started. Previously on Big Man Black T-Shirt. Next part is cam. Let's do it. Go from the model, top left here, down to cam. Now in cam, we've already got a setup here by default, but you have to put in another one. Create a new setup. New setup. Come over here and let's fill in the information on the new setup. This is where we tell it how big the wood is that we're cutting. It's already chosen the body by default, and that's what we want. It's already chosen the center of the piece by default, and that's what I want. Because like I said, I do mine all from the center. Now, if you're one of those people who likes wants your origin point not set in the middle, but set to the left front or even the left rear, if you're one of those people, you can just just click, put it where you want it. There, click that little circle and it puts it on your left front. Click here and it puts it on your left rear. So you can put it wherever you want it. I prefer mine here, but you can put yours where you like. We're milling. I'm going to leave both these where they are. For stock, by default, it adds 1 millimeter of stock in the sides and in the top. You see on the sides here, the shaded part on the far left and on the far right, that's 1 millimeter of stock it's added, and on the top it's also added 1 millimeter of stock. I don't truck with that, so I drop mine down to 0 and 0, so there's no stock added. None. No stock. And so you can see your dimensions, 86 mil by 36 mil. That's how big we want the part to start with. And our wood that we're cutting out is 12.4 mil. So that's how big this piece is. All that's going to be different is we're going to get rid of these corners for our fillets, and we're going to carve out these 2 slots here in the middle, and that's going to be our part. Click OK. Make sure your X, Y, and Z are in the right place. X usually goes to the right, Y goes back away from you, and Z goes up. That's where you got your origin point, so that's where your end mill, if you start from 0, which is centered, is going to start from the very center of your part. So now you got your setup. Now we're ready to go to the next exciting part. And that is 3D adaptive clearing. That's what I like to use for these pockets. When you do that, it's going to pop up here on the right. First thing you want to do is select which tool you're using. I have my tools already set up in the cloud and named it mine, and these are my tools that I've already put in. You measure them and make sure they're all correct and right and exact. And I'm going to use, I think I will use my number 1 tool, which is a 3.15 mil. That's 1/8 of an inch flat end mill. I'm going to use that one. That is an upcut. I'll show you why I'm using the upcut a little bit later. You could use a down cut and get a much nicer finish. Down cuts are really good for plywood. They really cut down on the fuzzies. But I'm going to use an upcut, and I'll show you why in a little bit. So we've chosen our tool, number 1, 3.15 mil. Coolant on this is disabled because I put in my tool parameters that I don't use coolant on anything. We're not going to worry about our speeds and feeds for now. Although these are all, you plug these in whenever you put your custom tools in there. You go ahead and put your default cutting feed rates and all that, but you can obviously change that later. We're going to go to geometry. Geometry is where we tell it what pockets do you want to cut. We're not doing any rest machining, so we'll turn that off. And now it's basically saying, what do you want to cut? What are we going to cut out? Well, we're going to cut this right here. Remember, these were 2 separate pieces, but once we finished it and we had the lines overlapping each other or meeting each other, and they're the same depth, it started treating it as one big pocket. So as we roll over the edge there, the bottom corner of the pocket, you can see that it selects the whole thing, both of those 2 little rectangles, because it sees them as one big pocket because they're the same depth. So click that. That's chosen your pocket. And that's it. You're done. We'll come back in and do some tweaking in a minute. But for now, just go ahead and hit OK and let it calculate that first tool path. Or not, if there's an issue. There you go. It's calculated your first toolpath. We'll go in and tweak it in a minute, but first just calculate it and just see if you're going to have any errors. Because you don't want to start tweaking for performance until you get rid of any errors that it might throw up. But it likes it. It has no problem with this. It's got plenty of space for that 3.15 mil tool to get in there. And so there's our first toolpath. That's our toolpath. We could go and cut this right now if we wanted to. But let's go in and edit a few things. Let's go in and poke around a little bit. Our heights should be set by default. We should be able to just leave those as they are. Passes. The first thing I like to look at is, well, you have to decide whether you're going to do climb or conventional. I like to do climb on interior pockets. And then you're looking at maximum roughing step down. This is how deep do you want your bit to go each step. Now what we're cutting is only 2.8 millimeters, but for an 1/8 inch end mill, that's a little more aggressive than I like to go. I'm going to back that off to 1.4. So we're going to do a maximum step down of 1.4. And we'll go in and put 0.4. That's our maximum step down. So stock to leave. We're not leaving any stock because we're not going to do a finishing pass. And we're doing a climb, maximum step down, machine cavities, rapid retract. We may do this later. We're going to go ahead and calculate that again. Now you see we've doubled. We've done 2 sets of tool paths. That's because the first time we did it, we had a maximum step down of, I believe, was it 10 millimeter or 14 millimeter? So it was just doing one cut at 2.8 millimeters, doing it all in one cut. I told it I don't want to be that aggressive. I backed it off so that the deepest it'll go with each cut is 1.4 millimeters. And so it says, well, if we're going to do 1.4 millimeters on a 2.8 millimeter pocket, we're going to have to make 2 passes. We're going to have to do 2 sets of tool paths. So that's what it did. It'll go in and do the first one at 1.4, then it'll come back and it'll do it again at 2.8, at which point you're done. So there's that. Now to keep this very rudimentary, the next thing we would do would be a 2D contour to cut the piece out. Piece out. It's already grabbed my number 1 tool, 3.15 mil. I'm going to continue using that tool. Yeah, we're going to stay there for now. Geometry, in other words, what are we cutting? Come down here and we are cutting that profile right there, or that contour, all the way around, including our fillets. Click that, and that's what it's going to cut. Now, while we're here, you have to decide how are you holding this piece of work down. Do you want tabs? So if you probably already understand about tabs to hold your stuff down, I'm going to go ahead and put some tabs in here. I've been experimenting with not using any tabs and just leaving like 0.1 or 0.2 mil of material all the way at the bottom and just letting the onion skin hold it down. But to keep it simple, we're going to use tabs. Now this is a small part. It's only 86 mil wide. I'm going to, you know what? I'm not going to do it. I was going to cut down on the number of tabs, but I don't know who's going to see this video. Let's start off conservative. But you can change the tabs by lowering the tab distance. You can spread the tabs farther apart. I've lowered the distance between tabs, and so it's able to cram more tabs in there. Right? That's if you go by distance. You can go by points, which is you go in by, golly, and you tell it where you want the tabs to be. I want a tab to be there. And spin it around, go to orbit. Spin it around, escape, and say I want another tab to be right there. Orbit. Spin it around, escape. I want another tab to be right there. Orbit. Spin it around, hit escape, and I want another tab to be right there. You can do that by putting them where you want them or by distance. I'm going to leave those there for now because I can. You tell them how wide you want the tabs to be. And the bottom line is how sturdy do these tabs need to be based on how strong this wood is, how big the part is, how aggressive your cuts are, how much stress you're putting on that wood. In other words, how likely is that wood to want to fly off the fly away from everything else after you've cut everything out. And if you're not putting that much stress on it, then you can make the tabs a little smaller, which will make cleanup easier later on. There'll be less for you to have to sand. But if you're really pushing your feeds and speeds and you're really taking out a deep cut every time, you may want to leave those tabs be a pretty good size. Otherwise, if they're too small and you're getting too aggressive with your tool, you can rip that piece out of there and sling it across the room or hit yourself upside the head. And now you've ruined somebody's day, most likely your own. But we're going to leave those tabs there. We're going to come on over to passes. And we're going to do multiple depths because we're doing a maximum roughing of 1 mil. We can jack that up to, I like to go about 1.4 mil on an 1/8 inch end mill. Pull this up here so we can see everything. I like to use even step downs. And let's go over to linking here. Rapid retract, lead ins and lead outs. We may get into that in a minute. And then entry position. That is simply where you want the cut on your 2D contour to start. I like to put mine kind of right in the middle. There might be a reason not to do that. We got a tab there though, right? Yeah, we have a tab there. So I'm going to move it over here. I don't want the entry to be the same place where there's a tab. Although, that probably wouldn't be a bad idea. You know what? I think I will move that back to roughly where that tab is. Because so far, every time I have an entry position, and the entry position is where it starts the cut, and that's also where it's going to change depth every time. Mine leaves a little ridge on the outside of the wall there wherever it changes the depth, and I haven't learned yet how to get rid of that. I think it has to do with lead in and lead out. But for now, I'm going to put that right there where that tab is going to be. So if I'm going to have to clean up the tab, I'm going to have to clean up that little bump there anyway. But yeah, I'll learn later on how to fix that. I'm going to hit OK. Let it calculate our 2D contour path. And we're going to orbit around a little bit. And you can see we got our tabs here at the bottom. There's our tab. There's our tab there on the end. And there's our 2D cutouts. That's going to cut the part out. So first off, we're pocketing out those two little slots. And then the second thing is we're doing a 2D cutout. And the only thing I haven't included here is I haven't done a tool change. I'm using the same size bit. So I'll tell you what I'm going to do right now because I'm feeling generous. I'll put in a tool change. So we'll go back to our sketch. We're going to right click and choose Edit Sketch. That removes all of our 3D stuff and goes back to the drawing board, so to speak. I'm going to put in just a small little something that I'll have to use a smaller end mill for, just so I can throw a tool change into the mix here. Let's see, this is a part I'm not actually going to use. I'm just doing this part just to show you guys what to do here. Yeah, let's put in a 3 mil polygon. There, we got us a 3 mil polygon. And we're going to put it, don't ask me what it's for, it's just there, just for the hell of it. We're going to put it, we're going to dimension that thing so that it is from the center to this construction line. We're going to make it 28 mil. And then from the center into this construction line, we're going to make it 10 mil. Nope. That won't work. We're going to change that to 6 mil. And we're going to change it again to 4 mil. There. And we're going to change it again to 2 mil. There, we're going to put a polygon there just for the bloody hell of it. We're going to get rid of that first. No, we're not. We're going to suppress those features. And then we're going to extrude our polygon. And we're going to make that be 12.4. Let's go 9 mil with that guy. Yeah. 9 mil. Then we're going to unsuppress those features. Yeah, that didn't work. Because it's there, but it's hidden. I just didn't want to have to do those fillets again, but oh well. We'll go in and we'll just... Can I edit the feature and get it back? Maybe. I bet we can't. Nope, we're going to have to delete it. It is deleted. Now we're going to have to create it again. 12.4. And this time you can see that it leaves out our polygon. Polygon is there. Now the only downside is we have to add the fillets back, but adding the fillets is easy. So 10 mil. Flip it around. Move it out of the way of that pop-up window that's coming. F for fillet again. Use that edge and that edge. 10 mil. Done. Orbit back around again. Actually, screw that. Just hit home to get our hero shot. So now that we have our trough there in the middle, and we've got our little polygon for our tool change, we'll do that with a smaller bit. So now we're going to come back over to cam. You can see that everything has changed. So we're going to generate our tool paths again. Oh, we can't because our body has changed. That body is missing. Yes, let's clear those selections. And yeah, the model's missing. So we're just simply click on there and put the model back. That happens sometimes whenever you change your extrusions. We're going to hit Command G and generate our tool paths again, and it's still not working. Oh, right. That got changed. So we'll delete that one and just simply put that back, and that should be fine. There we go. We're calculating that one now. There we go. There we go. And now we're going to do the same thing for our 2D cutout, 2D contour. Yes, we want to clear those. This happens sometimes whenever you make changes to your extrusion. You just have to go in and choose it all again. And it'll recalculate that, and that'll be just fine. And now what we're going to do is we're going to create another 2D adaptive for our polygon that we added. And we're going to change the tool so we can get in your tool change that some of you guys wanted to see. And we're going to change to a 1.2 mil down cut for this one. I've got a little 1.2 mil that I like using. And we're going to go to our pocket selections, rotate this down here so we can see, and we're going to choose that bottom pocket. We've chosen the pocket. And it has created a toolpath for that pocket. We're going to give that a name. That's going to be our polygon pocket. And this is going to be select it once and then select it again. It changes so you can rename it. We're just going to call this our slot pockets. And we'll just call this 2D contour or cutout. Now this is where you have to think of the order of what's going to happen here. This first one uses our 3.1 millimeter end mill. The cutout uses our 3.1 millimeter end mill. And this polygon uses our 1.2 millimeter end mill. And so that's how you want it. You want it to get all of your cuts with one tool done and then switch and do all the others. You don't want to have to switch from the 3.15 to the 1.2, then back to the 3.15 if you can help it. If you can help it, you don't want to have to do that. So we can either do our polygon first and then do our our pockets and our cutouts, or do those first. You're doing your cutout, so at the end of that, the piece is going to be less rigid than it would be earlier, because you're going to have cut most of it out except for the tabs. But this piece that we're doing here is very small. We're using a 1.2 mil end mill, so we're not going to be putting a lot of stress on it. So if you wanted to leave this last, it would probably be fine. But just for the heck of it, just to show you how to do it, I'm going to move that to where this is the first thing we do. And so to do that, you simply click and drag, and you should see the little lines popping up there that tells you that that's somewhere where you can drop it. We're going to come all the way to the top and drop it right there. And wonder why it didn't go. So we're going to do that again. And it went that time. So that is our first operation. Then there's our second operation, and we have to regenerate our toolpath for some reason. So we regenerate those. And there we have regenerated our toolpath. Oh, crap, I see what happened. It changed our tool, probably because I dropped that on it. Because you see this changed a whole lot with a whole lot of retractions. So we'll simply go in and change that back. I'm not sure why that got changed, but it did. I told you I'd screw up quite a few things. We'll go back to our number one tool, which is the 3.15. Hit OK, and that should regenerate our toolpath. I was going to say it still said 1.2 mil, but now it's changed back. And that looks a lot better. Now what I like to do is let's just choose Setup, which chooses all three of these, and let's simulate it. Let's do a simulate run. See how everything looks. Let's orbit this around so I can see everything. And we're going to choose transparent for the tool. And we're going to show the stock, and we're going to make the stock transparent. And let's simulate it. First thing you want to do is look down here on your timeline for any red hash marks. Any red hash marks shows a collision, basically meaning your tool is plunging into some wood that it hasn't previously cut, and it might be something you want to take a look at. It won't stop you. It'll still let you finish and run that program on your CNC. It'll just throw up a red hash mark to show you that, hey, this might be an area you might want to be concerned with. But I don't see any, so we're going to do a simulation run and see how it looks. There's our first run with the 1.2 mil. It's helixing into the cut. And then it's going in and cleaning up the the edges, all the little fine work there. And one thing you'll notice is I didn't put in a tool change on this, and I'll tell you why in a second. See, right there, it just went straight to the second operation, didn't give you a chance to change the tool, but that's because I'm going to export these or post-process these as two separate files. One as the 1.2 millimeter polygon file, and one as the two operations for these slot pockets and the cutout. So that'll be the tool change. It'll just be, I'll stop and I'll have to load the second code and I'll do the tool change then. There is a way in Fusion for you to put in a tool change if you ever get to that point, but I don't do that. I just make it 2 or 3 files, and then whenever I change the files, that's when I do my tool change. And so we're just watching here to see if there's any unexpected movements or anything. Basically use your simulation to solve problems before they happen. Because if there's problems with the tool doing something unexpected, you want it to happen here where you're not hurting the tool, you're not hurting the wood, you're not losing an eye because something broke off. Make your mistakes here. So always do the simulation and make sure that what's happening is what you want to happen. This is the second pass, so it should be done after this, and we should move on to the 2D contour. It's lagging a little bit, and I'm pretty sure that's because I'm running OBS to record this. So, yeah, that's why I'm getting the lag. Normally, this doesn't lag on Fusion. That's because I'm recording the screen at the same time. And that's doing a retract over there that it shouldn't be doing, so I'll go in and change that. See that retract? Yeah, that's unnecessary. We're going to jump to the end down here. So it's doing that retract that it shouldn't be doing. We'll go get rid of that. And there we are. So everything looks good. We'll just go in and make a few changes. And those changes are going to be, we're making some retracts on our cutout right over there. So we'll go to linking and look at, let's do keep tool down. And that may have done it right there. Let's do OK, and let's recalculate that tool path. Pull this. Let's do a simulate on just that tool path. See what we get. Yeah. It didn't retract that time. It just did this little lead in, lead out, and then drop down to the new depth. So there we go. We got rid of that. And then I also wanted to look at these slot pockets. Yeah, we got a retract there, but that's, yeah, we have to have that one to get back to the beginning. So that looks okay. And the polygon pocket, I think that looks all right. I did want to go in, though, and check on the multiple passes on that. Multiple depth, 0.75 on a 1.2 mil. That's probably okay. Yeah, 0.112. I think you want to go a quarter, so I don't know, we should probably back that off to about 0.6. Let's do that, and that'll give us some more passes. But yeah, that'll probably be okay right there. So we're going to go ahead and export this, post-process this, just this one polygon cutout, because that's one tool. We're going to click OK. I'll create a new folder for this. 86 millimeter test, because I like to keep it clean. And we're going to rename this to 1.2 millimeter poly pocket. We're going to click save. That'll throw up our G code file that I've set to open in Text Wrangler. Our Z-min, we're going down to 3.4. That is correct. Our 1.2 is our tool. I like to get rid of this T7 M6 here and put in a Z10. That should be fine. And now we're going to suppress this. And we do that because I had one operation, I could select that and export just that operation as a G-code file. This next step, I have two. Instead of selecting both of those, I'll just select setup, and I've suppressed this one. So by suppressing it, it's not going to export. It's just going to export these two, which will be both of our 3.15 millimeter cuts. And so we're going to post-process that. It'll take us to the same place. We're going to give it a name, which will be our pockets and cutout. We'll click save. It'll open up the G-code file again. We're going to check our distances. Yep, 12.4. That's how thick we're going. We're doing a full cut on that final cutout. I'm going to again get rid of this and put in a Z10, which just raises your spindle up to 10 millimeter, just as a safety thing. It's nice to get in there. And there's our slot pockets operations first that we're doing. And then we should have a contour, a 2D contour, cut out. I don't know if I'll actually see it. I may scroll right past it. Yeah, I scrolled right. That's good to go. We're going to close this. And while we do that, Fusion 360 is now going to be uploading that to my account. So we'll give that a second. It should have uploaded by now. We'll quit that. And one last thing I like to do, even though I've done a simulation from within Fusion 360. One of the last things I like to do is I use Camatics on Mac, but there are things you can do like this on your Windows and Linux computers too. This just is another simulation which lets you open the G-code files that you just outputted. Outputted, is that a word? And lets you check the actual G-code file. So we're going to do that. Because what we simulated a minute ago was inside Fusion 360. Well, if Fusion 360 screws up on the export of your G-code file, then that could make something happen that you didn't want to happen. So you also want to simulate your G-code file before you move over to the machine, and to keep you from breaking bits, wasting wood, or losing an eye, or worse. We'll zoom out here. Remember, this is just the polygon with the 1.2, so we'll play that and just make sure what we think is supposed to happen is actually happening, and only what is supposed to happen is happening. It up a little bit. I think that looks okay. It's not doing anything it shouldn't be doing. There we go, that's fine. Then we're going to open up the other one, the pockets and the cutout. And let's spin this right. Let's run that and see how it looks. There are the slots that it's running down the middle. Pockets running down the middle. And now we're doing our cutout. I'm running this really fast because I'm pretty sure that everything's okay. That looks fine. Connect to the machine. And home the machine. And let's see, we're already in inches here for fast movement. So I'm going to come over and get close to the center line as I've marked it on my stock. Jog over to that. And before I center it in, I've got in right now the 3.15 millimeter end mill. And because we have three separate cuts to make with two separate size end mills, I'm going to change out this guy now, and I'm going to do the 1.2 millimeter down cut operations first. So I'm going to take the 315 out, and I'm going to put in the 1.2. This is a 1.2 millimeter down cut to cut out that little octagon. And again, I put that octagon in there, and I'm doing this just because one of the requests for this video was to show how I handle, or how most people handle, a tool change. Like I said, I just do it, the simple way by running two separate operations. And so there's that tool in there, and so now I'll leave it in inches and jog down till I get closer. That's pretty close. Now I switch back to millimeter because that gives me a much shorter step position, and I use millimeter to make really small movements to get me exactly on those crosshairs for my center position. And you just have to eyeball it. Good thing about starting in the center is, you can be off by a little bit, and you're starting in the center of your stock, so you usually don't have to worry about running out of material on the far left or right or up or down or far X, Y positions, because you're starting in the center. That's why I like to start in the center. It gives me a little extra slop to make up for my lack of accuracy. So I'll double tap the X to zero that out, double tap the Y to zero that out, and now my X and Y are set right to the center of that stock that I'm going to be cutting. And next I'll set my Z. I used to use a piece of paper for this. You can use a feeler gauge, basically anything with which the thickness of it. I use this is some double-sided tape. This is the little 3M backing that peeled off of it. I had a bunch of those laying around, and this is very, very thin. And so I use this, and I've got my increments set to 0.1 millimeters, and so I just add 0.1 millimeters after I do this. And so I just come in and I jog down slowly while moving the strip around, and I just wait till I feel the end mill start to drag on the strip, which it did right there. I keep pulling, and I'll just go ahead and pull that out, and then I'll add a couple more shots, which takes it down another 0.2 millimeters, and that's at the top of my stock. I'll go in and double tap the Z, and now I've set the Z on my stock. Just to make sure, just because I'm OCD like this, I'll go up, and after I've set those, I'll hit return to 0, just to make sure everything has been zeroed, although I know it has. If it hasn't been, and you do that, it's going to fly no telling where, so maybe eliminate that step. Never mind. So my X, Y, and Z are set to the center of the stock. I've got the 1.2 millimeter end mill in, so now I need to go and load up my 1.2 millimeter operation. Check your visualizer to make sure it looks roughly like what you're supposed to be supposed to be cutting. That does. I'm going to check your dimensions here, see if that's roughly what your dimensions should be. It is. And so my center is set. My center is set to the center of this, not the center of that. So when I hit run, this spindle is going to take off and it's going to come over here somewhere and cut the octagon wherever I had it on the part, probably about right there. The center is set. That's set. All it's left now to do is hit go and turn on the spindle. And I'll do that, and then you'll hear another noise kick in as I get up and grab the vacuum to keep that vacuum out, because this is a down cutting bit, and I don't want to make it too rough on it. So I'll put on my goggles because I don't want to lose an eye. Alright, I've stopped the operation, and I'll tell you why. After I go back to inches and raise my end mill up so I don't screw anything up, I'll return it to 0 and go back to mill. Some of you can probably guess why I did this, but it was ramping in, or helixing in way too slow. Now that's not a big deal. It was almost done. I could have just let it go, but this is a good teaching opportunity to show you what to do if you do that. I should have simulated that, and I should have remembered that by default it ramps in kind of slow. And so I'm going to go back to Fusion 360, run that signal, run that again, and change that and make that faster. So let's go do that. We're going to change this. And remember, we suppressed it earlier, so we're going to unsuppress it. Move the suppress check mark. That'll let us work on it again. We're not going to worry about generating the toolpaths again because we're going to have to regenerate them anyway. And so this is for the helix, if you'll remember, or for the, let's generate them again anyway, just so to show it. This is for this guy, this little polygon we're cutting here. Actually, it's a 1, 2, 3, 4, 6, so it's a octagon. No, octagon is 5. Hexagon is 6. So this is a little hexagon. And the helixing in, the plunge in, is taking way too long. And so if you had a bunch of these to cut, you don't want to wait that long. You want to get this thing going here. So, and it's good to go slow, but not that slow. I believe it's under linking. And let's look at ramp clearance. Yeah, we're at 2.5 mil. Let's drop that down to 0.5 mil. Still seems pretty high. Anything, it looks like it went higher. How the hell did it go higher? Oh, it went to 5 instead of 0.5. Oh, there you go. 0.5? Well, you guys probably saw it on the video and I didn't. 0.5, is it going to stick with 0.5? Yeah. Okay. Well, that's why I went higher, because I doubled it. Okay, so there you can see our ramp is just barely above the top of the stock. So that should get us in there a lot quicker now. Yeah, we're cutting just very little bit of air before we start cutting wood. Once you start cutting wood, then the speed picks up. Yeah, that's better. All right. Well, you get to see me do some screwing up. I'm gonna leave everything else as it is. We're gonna post this out, and we'll overwrite that other one, 1.2 Poly Pocket. Click on it, and it takes on the name. We're gonna overwrite it, place it. And remember, we're going to change this to a Z10, 3.4, 1.2, everything else looks good. We're going to save it. And we're back over at the other computer. And we're going to load up the file, which has auto-magically synced over here. To make sure, we'll check the save date, 5:05 p.m. It's now 5:07 p.m. So that's it. So that's our new file with the lower height for which it's going to start the ramp. Turn to 0. We are back to where we started. We should be ready to just fire this up and cut. Put my safety goggles on, because I only have 2 eyes and I like them. Here we go. Alright, so there's our first operation with our first end mill. That goes down cuts on plywood. They look nice. Nice finish. So simply leave everything where it was. And that's the way I do it. Be careful as you're taking this off that you don't manhandle it too much and make this jump and jive and wail and make your belt skip a notch. That'll throw everything off. Not quite enough room, so let's go back to inches and let's jog this up a little bit. There we go. Pull that 1.2 down cut out of there. And we'll put the 3.15 mil up cut back in there. And again, I'm just using up cut just because I am. There's a tautology for you. I always tend to get this backwards. Oh, yep. Told you, always get it backwards. Actually, I don't usually get it backwards. I probably got it backwards that time because the camera was running. Because you guys are watching me. Stop watching me. I get nervous. I get stage fright. Alright, we're going to drop her back down, get in the vicinity. Alright, now our X and our Y haven't changed, right? But our Z has. So here's what I do, because, you know, and this is a safety issue here where I just don't want to break bits. Especially if I were going from a thicker bit like this 1/8 down to a 1.2, which is more fragile and easier to break if I jam it into the wood. And so what I do, just for the heck of it, is I'll drop the Z down a little bit, but not too close to the wood. And then I'll reset the Z right there. Then I'll hit return to 0, to go back to my X and my Y 0, and I'm going to reset the Z anyway, but I locked it in there so that when I hit return to 0, it didn't try to return to 0 on the previous Z, which might have been different, and it might have jammed my end mill into my wood. So I set it intentionally quite a bit higher, hit return to 0, and it goes back to my X and Y zeros. That's just the way I like to do it. You can do it however you want to do it. So now we just need to set our Z again, that's all. So I'll change this back to millimeters to give me the real short steps and do that process all over again. We're starting from pretty high up, so I should have jogged it down a little closer. And so there we go. I jog and move, stick and move until I feel a drag on the paper. There's a drag. There's another drag. Pull it out and give it another shot. Previously I gave it 2 shots. This time I went down until I felt a tighter drag, so I only gave it 1 shot. And now we're at our 0. I double tap the Z again, and then we've set our 0. Hit return to 0, and there we are. And we're ready to go. We're ready to cut this next piece. This will take a lot longer, but through the magic of video editing, you won't have to sit through it all. And let's load up our other operation, our other G-code file for pockets and cutout. Take a look at it, make sure that's going to do what we want it to do. It's going to run our pocket operations here in 2 passes, 1.4 mil each, to clear out these 2 slots in the middle. And it's going to come out here and do the cutout with a tab on each broadside. So here we go. So I don't know how many of you caught that, but boy did I just get lucky. Did you catch it? I only had 1 tab in there. I thought I had one here and here and here, and I only had 1 tab holding this son of a gun. I just got lucky. Alright, so there's the finished cut. And here are a few shots of it all cleaned up afterwards, and after I ran a trace operation over the top of those nasty upcuts. I'll do a video probably next after this one showing you how to do some cleanup with trace operations or some chamfer operations. But I hope this 2-part series answered some of your questions, and if not, hit me up in the comment section and I'll do some more videos if that'll help you guys out, and I hope you learn from my mistakes. I always do. I usually do. Sometimes I do. Thanks for watching, guys.